metals at the base of group 4 show variable valence with a maximum valence of 4. Tin is a shiny grey metal and non-poisonous. The Romans called it stannum, hence its symbol Sn. Its ore is tin oxide called cassiterite, a granite mineral mined and processed in Cornwall, Britain from 2250 BC. Alloyed with copper, it made bronze, the first widely used metal. We use tin to line steel food cans to prevent them from rusting. They work fine until the can is damaged. The can rusts, swells, and the growing bacteria inside can kill. Lead is a nastier chemical as it is poisonous, particularly to young children whose bodies are growing. It causes brain damage, behavioural problems and digestive upsets. Our harbours are full of it because of red lead oxide paint used to coat ships and bridges. Australia was very slow to reduce its use in petrol and house paint. Lead sheeting is still placed under roof tiles by some builders. Most of our car batteries contain lead and should not be dumped but recycled. The Romans poisoned themselves using lead in their water pipes. It was their plumbing material, hence the symbol for lead, PB for Plumbum. Be careful if you are renovating old weatherboard houses full of lead paint. Just sanding the walls without proper vacuum equipment is quite dangerous. Fertiliser companies often place NPK number quantities on their products. They are the three most important elements that plants need to grow. Group 5 of the periodic table begins with the nonmetals N for nitrogen and P for phosphorus. Nitrogen is a very unreactive gas, with 2 atoms in its molecules. Colourless, odourless and tasteless, it makes up 78% of the air that we breathe, and unlike oxygen, our bodies do not use it. The planet has its own violent ways of converting nitrogen to more reactive chemicals, and we humans have added to this violence by unbalancing the nitrogen cycle. Thunderstorms are dramatic events. The intense heat of lightning strikes reacts oxygen and nitrogen gases together to form nitric oxide. This reacts, forming brown acidic nitrogen dioxide plus ozone. Both have an unpleasant smell and attack the lungs. Nitrogen dioxide dissolves in rain, forming nitric acid, a nasty chemical that can dissolve human flesh in concentrated form. It triggers asthma and attempts to acidify oceans which are normally mildly alkaline. The Sydney Basin traps brown photochemical smog using a process called temperature inversion. In each of China and India, 1 million people die each year from air pollution. Nitric oxide is one of a dozen chemicals that reduces the lifespans of smokers of all kinds. We should rightly blame power stations, steelworks and electrical furnaces for adding to the woes of our very thin atmosphere. We must demand stringent anti-pollution gear on smokestacks. But there is another problem. Our cars have their own lightning makers in the form of spark plugs. Engines emit carbon monoxide and nitric oxide from their exhausts. To slow these emissions, modern cars have expensive catalytic converters fitted to convert these two nasties to carbon dioxide and nitrogen. They are not always efficient, so anti-pollution gear should be compulsory in all road tunnels. In a big city like Sydney, slow wood heaters add to the city's smog in winter, emitting carbon monoxide, tars, nitrogen dioxide and fine particulates that penetrate the lungs. So if you have one, please throw out this dangerous antique. Plants need nitrogen to make their DNA and amino acids in living protein. The Lord's small living things help them process nitrogen in a more balanced way. There are nitrogen-fixing bacteria that make nitrate, ammonium and nitrite ions that plants can absorb. Then there are denitrifying bacteria that convert them back again. Farmers know all about legume plants that increase soil fertility. They call them green manures. Legume plants include clover, peas and beans, and good old Aussie wattles. Legumes have nodules in their roots containing nitrogen-fixing bacteria. In 1669, German alchemist Henning Brandt boiled urine to dryness in a retort and kept on heating. The result was a liquid that kept bursting into flames and glowed in the dark. He had discovered phosphorus. Solid phosphorus is quite reactive and found only in nature as compounds. White phosphorus is the horrible form. It bursts into flames when dry, making it useful in war, and will poison and rot your bones if you are silly enough to play with it. The less reactive form is the red phosphorus that we use on the sides of matchboxes. It burns, forming an acrid-smelling white smoke called phosphorus pentoxide. Dissolved in water, it forms phosphoric acid, used as a preservative in cheap soft drinks. The colour, sugar, preservative ones that too many people drink. Phosphate chemicals needed for plants to grow are not all that common. When the British population exploded during the First Industrial Revolution, the richer farmers used every form of phosphorus that they could find, including ground-up dinosaur poo and the bones of soldiers from the old Waterloo battlefield. In Australia, we relied on fossil guano, which is the accumulated sun-dried bird poo that coated the island of Nauru. This is now mined out, leaving the locals somewhat devastated. In many countries, raw sewage is bucketed directly onto crops as a source of phosphorus. A natural mineral source of phosphorus is apatite, found in the black volcanic rock basalt. Australian soils are depleted in phosphorus because our volcanoes are no longer active. We need to cherish those black soil plains that survive today. The problem with our world's driest continent is one of eutrophication. Our sewers are old, leaking and overflow during rain. We concrete down to the waterline and fill the few existing paths with dog poo. In the country, cattle graze right up to the riverbanks. Our once clear streams and rivers and sea turn green as green algae grow rapidly in water heavy with silt. Algae grow fast and die fast. Then they sink to the bottom and decay organisms appear, grow and use the available oxygen in the water. Fish die and rivers stink. We are starting to see the red tide on our coastal beaches. Humans cannot swim in that sort of water. You might like to colour in these important elements on a periodic table and review in your mind some information about each.